So we're going to do our 4.4 notes, which is multiplying matrices. I will tell you that at first you're going to look at this and think it looks very difficult, okay? It's one of those things that you have to practice and keep practicing, and then it becomes really easy. It's kind of like learning how to juggle. You look at someone and you're like, wow, that looks really cool, let me try, and then it's just like, they go everywhere, right? But if you learn and you keep practicing, it will get easier, and then people can make it look like simple. I can't juggle, but if I could, you know. So it is something that you just have to practice and get into the pattern, and then it becomes much easier. So our goal today is to learn matrix properties and to multiply matrices. We're going to start with multiplying. Now, this is where I was saying that you have to be able to identify the dimensions of a matrix, okay? And when we were adding them, they had to have the same dimensions. When we multiply them, they do not have to have the same dimensions. They could have the same dimensions, but there's something else that is more important. It's that the number of columns in the first have to match the number of rows in the second. So let me show you what I mean. When you multiply A times B, it's a fruit fly. A times B, you are multiplying a 3 by 4 matrix times a 4 by 2 matrix. So you're going to look at the columns of the first matrix and the rows of the second matrix. So these two numbers here. If those numbers match, that means we can multiply them. Okay? Excuse me. And if we can multiply them, our product, which is the answer to the multiplication problem, is going to be a 3 by 2 matrix. Okay, your 4s match, and then your answer is the outside, 3 by 2. Now a 2 by 3 or a 3 by 2 are not the same matrix. Okay? And if you're multiplying A times B or B times A, those are not the same problem. Order matters. Okay? When you're multiplying matrices, the commutative property, which tells you if you add or multiply like 3 times 4 or 3 plus 4, and you switch the order, when we're talking about real numbers, like 3 and 4, those are integers or natural numbers. When you add or subtract them or multiply them, it doesn't matter the order that you do them in, right? But it does when we're talking about matrices. Okay, order matters. Okay, it didn't in the adding. It would in subtracting. Okay, but it does also in multiplication. Order will matter. So this next one, when you multiply A times B, we're going to have 5 by 3 times 5 by 4. When you look at those inside numbers, did they match? No. So our answer is going to be undefined or not possible. Okay, now your explanation would be you have to write this out, and then you can just say, does not match. That's your explanation, because if you write not possible for a problem, you have to give me a reason why. Okay, so there's your reasoning. You write this out, you show me those do not match, does not match. And if those don't match, then you can't move on and it's not possible. Does that make sense? The next one is a 3 by 3 times a 2 by 3. Can you multiply these? No. And then we'll use that explanation right there too. Okay. Now that's if I did A times B. What if I did B times A though? What would be the dimension of the first one for B? A 2 by 3 times, what are the dimensions of A? A 3 by 3. Can you multiply these? Yes. Since those match, you can multiply them. What's your answer? What's the product going to have as dimensions? A 2 by 3. Okay. Now that part is usually the easy part to understand. Okay. The next one, I am not going to read these steps. You can read them on your own. We are just going to try these. Okay? Because the pattern is what's important. And you have to pick up on that algorithm, the pattern that you follow every time. And until you've done it a couple of times, it's going to be like, whoa, what's going on? I promise it will be like that, and I apologize. But just do it a couple of times, get through it, and it becomes a pattern that is very easy for you to do. Does that make sense? It's kind of like a little toddler learning how to walk. And next thing you know, there they are running. Is walking difficult for you? Probably not, because you practice it. You keep doing it every day. Walking becomes easy. Okay? Because it's a pattern. It's something that you do every day. So, x times y, let's write out the problem. X is 6, negative 3, negative 10, negative 2. Y is negative 5, negative 4, 3, 3. First, what we're going to have to do is we're going to have to figure out the dimensions of the first and the dimensions of the second. So what are the dimensions of x? A 2 by 2. Times, what are the dimensions of y? A 2 by 2. Can we multiply these? Yes. What is our answer going to be? A 2 by 2, because those are the numbers that are left on the outside. Are you with me so far? So, our workbox is going to be pretty in-depth here. So what I usually recommend doing is drawing your workbox as a 2 by 2. And then we'll have actually our answer as a 2 by 2. But make your workbox very large because it's important that you have a lot of room to show your work. So, this is the first row, first column. Okay? So what we're going to do is rows always come before columns. So for this box right here, we have to use the first row, the first column. And the reason why there are 2 elements circled here and there are 2 elements circled here, because those 2's matched. If they were 3's, there'd be 3 and 3. If they were 4's, there'd be 4 and 4. But the numbers will match. They each have a partner. So 6 matches with negative 5, so you multiply those together. Plus, negative 3 will match with 3. If I had another one, I would keep going down and over, down and over, down and over. And they'd each have a partner. And you're multiplying the partners, and then you're going to add those all up. So I can, from there, type that into my calculator, or I could just do it. That would be negative 30 minus 9, right, which is negative 39. But if I didn't want to do that math, I could type in 6 times negative 5 plus negative 3 times 3, and it will also tell me that's negative 39 for that box there. Again, this is just going to get in the habit. So you're going to use first row, but that's second column, so now we're using second column. You're always going to use the rows in the first and the columns in the second. So 6 and negative 4 are partners, plus negative 3 and 3 are partners. Add those up. So we have negative 24 and negative 9 is negative 33. Also, if you didn't want to do that, you could type in the whole thing. Negative 33. When you move down to the second row, now we're going to use the second row, but we're in the first column, so we're going to use the first column. Negative 10 times negative 5 plus negative 2 times 3. That's going to turn to a positive 50 and negative 6. So 50 minus 6 is 44. And then I have the second row, second column. Negative 10 times negative 4 plus negative 2 times 3. Positive 40 plus negative 6 would be 34. Okay. Now again, this is just going to take practice. It is not something that you're going to be like, oh, I totally get it right now. Maybe you're like, okay, I followed it, but it's just going to take some practice. So let's try z times x. Am I good to scroll or push this over? Are we still writing? I think I still have some writers. Okay, so z times x. The first thing you're going to do is let's write out the problem. Z is 1, 2, negative 3, negative 4, 5, negative 6. X is 6, negative 3, negative 10, negative 2. What are the dimensions of this first matrix? How many rows? How many columns? A 3 by 2. So I have a 3 by 2 times, what are the dimensions of the X matrix? 2 by 2. So look at those inside numbers there. If they match, we can multiply them. Can we multiply them? Yep. What is our answer going to be? What dimensions? A 3 by 2. So that means my workbox here is going to have 3 rows and 2 columns. Again, I'm going to make sure that that's fairly large. Again, I have a 2 on the inside, so when I do my circling, there's going to be 2 elements there. So, first row, first column. First row, first column. There's 2 elements and 2 elements match because 1 and 6 are a pair, plus 2 and negative 10 are a pair. Six and negative 20 is going to be negative 14. Are we okay so far? All right, let's change colors. First row, second column, so still using first row, but now I'm going to use the second column. So I have 1 and negative 3 are partners, plus 2 and negative 2 are partners. Negative 3 minus 4 is negative 7. I'm moving down to my second row. I'm going to use the first column because I'm in the first column. Negative 3 and 6 are partners. Negative 4 and negative 10 are partners. Negative 18 plus 40, you're going to get 22 in that location for that element. Middle row, second column, negative 3 times 3 plus negative 4 times negative 2. Negative 9 plus 8. No, wait a minute. Sorry, that's negative 3 times negative 3. 9 plus 8 is 17. Okay. Then, last row, first column, 5 times 6 plus negative 6 times negative 10. That'll be 30 and 60. So that element is going to be 90. Last row, last column, 5 times negative 3 plus negative 6 times negative 2. And I'm going to show you kind of a trick of your workbox. So some people do their whole workbox and then figure out this, or you can do one box at a time. It doesn't matter. So negative 15 plus 12 is negative 3. Okay, so what I want to show you, so make sure you have that finished writing it down, and I'm going to show you. In the first column is 6 and negative 10. 6 and negative 10, 6 and negative 10, 6 and negative 10 in your whole first column. In your second column that you use, negative 3, negative 2, negative 3, negative 2, negative 3, negative 2, negative 3, negative 2. So you should be able to see that right in your workbox. In the first row, you have 1 and 2, 1 and 2, 1 and 2. In the middle row, negative 3, negative 4, negative 3, negative 4, negative 3, negative 4. In the last row, 5, negative 6, 5, negative 6, 5, negative 6. In that whole last row. So you can double check your workbox before you even move on to finding the actual answers. So make sure that in your column, you see what you're supposed to see in that first column for that second part. What do you see in the second column? What do you see for the second column? What do you see for the first numbers in the first row? You kind of follow what I'm looking at there? So that will kind of help you to decide if your workbox, that's how I caught that negative 3 that I missed, because I looked at the previous up here and I said, oh shoot, that's supposed to be a negative. And I went back and changed it because I knew it was supposed to be negative. So it's always good to double check that once you have that whole workbox. This is required. This is how you show your work. Okay, this is required. And then obviously you need your answer. But that's how you show your work. On the back side, there's a couple things that it goes over. Okay? The first one, it says test the commutative property. I did not make us actually do these multiplication problems because it would take us forever if we tried all of these. Okay? But I showed you what you get when you have G times H. So I want to show you. If you multiply G times H, here's your first row. Here's your first column. That's what's in this first box. 1 times 2 is 2. 3 times negative 2 is negative 6. Negative 5 times 1 is negative 5. Then when you add those together, we got negative 9. Okay. Notice that this one was a 2 by 3 times a 3 by 2. So our 3's are what match on those inside, and our result, our answer, was only a 2 by 2 matrix. But that's why we have 3 different pairs that were multiplied that we have to add up in these ones. Okay, that's why I wanted to show you that. Okay, your first row, second column, 1 times 3 is 3. 3 times negative 8 is negative 24. Negative 5 times 7 is negative 35. That's where that one went. Your second row, first column, second row, first column. 4 times 2 is 8. Negative 2 times negative 2 is positive 4. 0 times anything is 0. That's where that answer is. And then the last one, this one here, is a second row, second column. So 3 times 4 is 12, negative 2 times negative 8, 16, 0 times anything, 0. Okay? Then when they added all those up, these are our singular elements that we get. When you multiply it the other way, though, your answer is a 3 by 3 matrix. If you multiply H times G, then what we would have, H was a 3 by 2 times a 2 by 3. You can see right away that we're not getting the same thing because our answer here is a 3 by 3 matrix, which is different than a 2 by 2 matrix. You get two completely different answers, even if you can multiply them both directions. Okay, so what I'm showing you is that the commutative property is it's not going to be true. The commutative property does not work for multiplying matrices. Okay, so we can conclude that the commutative property, so the order of multiplying, commutative property of multiplication, so specifically, is not true when multiplying matrices. I wanted to show you this so you know that the order that the multiplication is given to you has to remain in that order. You cannot change it. You cannot change the order of multiplication when we're dealing with matrices. The distributive property, okay? If you have a matrix multiplied by two matrices added together, just like PEMDAS, we would first have to add these together and then multiply by J. J is obviously in front of this sum. You could also distribute J through, and that's what we're going to test. Is it the same thing? And when we do the adding first and then multiply the matrices, this is what we get. If we multiply these two, J times K and J times L, and then we add those, this is what we get. Did we get the same thing? And since we did, we can conclude that the distributive property does apply to matrices. Now the last four are, I could have shown them to you, but I didn't. So the associative property of a matrix, these are properties of matrix multiplications for any matrices A, B, and C, which the matrix product is defined, and any scalar K. So that's where the scalar K is that constant out front. So it's important that you think about A, B, and C are matrices, right here. A, B, and C are matrices, okay? K is your constant. K is just a number. It's not a matrix, okay? The associative property says that you can group different things together. So for instance, if I was doing this with multiplication and I said to multiply A times B times C together, those are three matrices being multiplied together. I could choose to multiply A times B and then take that answer and say that times C. I could do it that way. Or that's the same thing as if you multiplied B times C together, had that answer, and then did A times that answer. So it doesn't matter which two you decide to multiply first. You're going to multiply two of them and then take that answer and multiply by the third one. Okay, but you're not allowed to change the order of them. Okay, so A, B, and C, notice that they're always in that same order. I did not change the order of them because the commutative property is not true. It does not work with matrices. The associative property of scalar multiplication. This one is with a scalar. So if you have a scalar, we'll say K, and then you have a matrix A and a matrix B that are multiplied. Okay, you can choose to multiply K by A, take that answer and then multiply by b. Or you could have a out front and multiply k by b, and then take a and multiply by that answer. It does not matter when you have scalar multiplication. Okay. And then the distributive property is what we showed up here, this up here. But the idea is that if you have a matrix and A was on the left side, when you distribute it, A has to remain on the left side. It cannot move to the right side because then you'd be changing the order of the multiplication. So if you wanted to distribute it, you'd have to keep A in front of both of those. Does that make sense? Because it was on the left side. Similarly, if we had B plus C times A, like this, and you wanted to distribute that A in, A would have to remain on the right side of both of those matrices. Okay, and that's what it means when we are distributing, is you cannot change the order still. Now, typically, it's a lot easier to add, so I would probably add and then only do multiplication one time, unless you, in previous answers, already have these two things. Then it might make sense to do that. The next page is your assignment. Okay, so you guys have almost a half hour to finish up your 4.3 and work on 4.4. 1 through 9, you need to show me what the product is going to be. What are the dimensions of the product going to be? If you write not possible, I need a reason. Okay, so remember I showed you how to write out that reason. Show me the dimensions. Show me that those middle two numbers do not match. For 10 through 13, make sure you have your dimensions written out so you know how to do your work box. The problem's already there. So you have a work box, and then you'll have your answer. Same with on 14 through 17. Make sure you have a work box, and then you'll have your answer. Does that make sense? After you figure out the dimensions. If you have questions, let me know.